All right, so our focus today is to talk about derivatives and the power rule. And you've probably heard me kind of say this word a few times already. A derivative is one of the most important things that you'll talk about if you take calculus. And if you're signed up for differential calculus next year, it is pretty much 3.5 quarters of finding derivatives and looking at how they're used and all the different ways and different rules that you have for derivatives. When you find a derivative, it's called differentiating. That's why it's called differential calculus. So if you take it next year, you'll experience that. If you go to college and take a calculus class next year, the first part of your college class will be talking about derivatives. And then you'll get into antiderivatives and all this other kind of fun stuff. But for today, I want us to just understand what a derivative is. So yesterday, we talked about the idea of the slope of a tangent line. Can be found using our limit. And this thing we've talked about now a few days this week. But here's the thing. That idea of the slope of a tangent line is called a derivative. So what we were doing when we were finding the slope of the tangent line and using this limit was actually finding a derivative. So this is called the derivative. So without even knowing what we were doing, we were finding the derivative of a function. And the reason we find the derivative of the function, there's lots of them. At its most basic definition, it tells us the slope of a tangent line to a function, but it can be used to talk about different rates of change of lots of different ideas. And we talk about how the slope represents a rate of change. So when we're finding a derivative, we're really finding a rate of change. So it's a pretty important concept. What I want to do today is look at some functions that we've done with the limit and see if we can start to find a shortcut for this process. So we're going to look for a shortcut. And I'll just put this up here. I did it up on the board earlier. But this way I can have it posted in the video. So I'm going to put up a couple of functions. And then I'm going to tell you what the derivative is. And then maybe I'll have you guys give me some functions. And I'll tell you what the derivative is. And the goal would be that you can find the shortcut for how we find the derivative using this power rule. So let's say our function is x squared plus 3x minus 5. Oh, before we get to that, I apologize. We need some notation. So let's go just up by the idea. I lost my zoomer guy. How do we write the derivative? So we use the following notation. And there's really one that we use a lot to represent a derivative, and that is f with like a little dash. It's not a 1, okay? It's a little dash. We read this as f prime of x. Generally speaking, this is the one that we use the most, or at least the one that you'll see the most initially. As you move further into calculus, you may see some other notation. Dy over dx is another common one. And again, it represents a rate, change in y over change in x. That's really what that's saying. Sometimes you might even see delta y over delta x. I'm not going to write that one, though. How about y prime is another one that's sometimes used. So there are a few different notations. The one that we are going to probably see the most often is this first one. Like that's the one that I'm going to use more often than not, and the one that when you start calculus, you'll see. So I needed that because when I give you a function, I want to be able to give you the derivative for that function. And I write that as f prime of x equals. So that is our derivative. And I'm just going to put a few functions up here. F of x equals, so f of x equals 3x to the 5th minus 4x cubed plus 7. The derivative of that is 15x to the 4th minus 12x squared. And again, I'm just going to put a bunch up here, maybe one more, and then I'll have you guys give me a function that you want to look at. So f of x equals 1/2 x to the 4th minus 2/3 x cubed. And the derivative would be 2x cubed minus 2x squared.
Wait, I don't know how do you figure that out?
That's what we're trying to figure that out right now.
What is she doing?
I want you guys to start looking for some patterns. What do you see?
Okay.
Do I say the pattern I see, or do you want to point?
Give me a function. Well, how about this? I'll give you a function and you try to tell me what the derivative is, and we'll see if your pattern is correct, okay? So if I gave you the function, let's say 7x cubed minus 10x squared plus x, let's go minus 1. What do you think the derivative is?
21x minus 20x plus x.
You're close. You're really close.
I don't know what to do with the x.
Yes. So you've got the first part of this process. So explain how you got your 21.
You just take the power of whatever it is and multiply it by the number of x. I forget what that's called.
The coefficient, yeah. So 3 times 7 gives us 21. 2 times 10 gave us 20. I like that part of it. Now let's look at some of the other ones and see if we can figure out the rest of it. So for this one, I took 4 times 1/2 and got 2. But what do I do with that power? I took,
You subtracted 1.
yeah, 3 times 2/3 gave me 2, but then the power reduces by 1. So going back to the one we have over here, what do you think the power would be on 21x?
Squared.
Yep. And then minus 20x. I like that part. And then what would that next term be?
Plus 1.
Perfect. Now I want to point something out because I wasn't writing this piece of it, but for each of the constant terms. So in that first one, that minus 5, I would have written plus 0. For the 7, I would have written plus 0. For the minus 1, the derivative is 0. I don't have to write that, so I didn't, but that's why you're not seeing anything for that piece of it. So let's try one more. Yeah, let's make it a little more interesting. So let's see, f of x equals negative 5x to the 7th plus 3x to the 4th minus 2/3 x squared plus pi.
Negative 35x to the 6th plus 12x to the 3rd minus 4/3 x.
Yeah, I tried to trick you on that one. So the process is the same, right? We're taking whatever that exponent is, 7, in this case, multiplied by negative 5. That gives me negative 35. And then I take the 7 and reduce 1. I take the 4, multiply it by whatever my coefficient is, which is 3. That gives me 12. And then reduce that power by 1. Take the 2, multiply by negative 2/3, that gives me negative 4/3, reduce that power by 1. And then pi This is just a constant. It's just like all of our other constants. Pi is 3.14. There's no x there, which means the derivative of that is going to be 0. If I ask you to find the derivative of a number without an x in it, it's always 0. So let me try, we're going to just kind of keep exploring this a little bit because there's lots of different things that we can do with this. What if I gave you something that looked like this? F of x equals x to the negative 2 power. So think about what that might be. Take a second, write it down, and then I'll have one of you share it with me, what you think it is. Okay, what is going to be the number in front of x for this one? Yep, take that negative 2, multiply it by your coefficient. Our coefficient here is just 1, okay? So we get negative 2, x. Now, what power is it going to have? Good. We're going to reduce that power by 1. So it says reducing a power by 1 is the same as saying subtract. So we take that negative 2 and we subtract 1 to get the new power of negative 3. Now, I like this. That is a correct derivative. I'd like to maybe challenge you a little bit. And this is why we talked about what we did on Monday. That idea of negative exponents is going to show up in derivatives. So all of these sort of interrelated or independent topics that we've talked about this week actually all come together with this idea of a derivative. I can rewrite this so that negative exponent is not negative anymore, right? Remember on Monday, we talked about how we can take that exponent, and if it has a negative, or that term, that base, and if it has a negative exponent, rewrite it so that the exponent is not negative. So I could rewrite this as negative 2, and I could think of it as times 1 over x cubed, or I could write it as over x cubed. This process of rewriting it so the exponent isn't negative is kind of important, but for us this year, if you can get here, I'm pretty happy. This is where you're going to have to get next year if you take calculus. But if you can do it now, fantastic. Yep.
So we can go back to that one time we did the notes with the f of x plus h minus f of x, and we can literally just do that and it'll give us
You will. It's a way of checking your answers. Yes. Now on that assignment, I do want you to practice with that limit.
Okay.
Yeah. So the limit is important. It's something that you're going to see even when you start calculus next year. You're going to start out with that definition of the derivative, which is the limit, because that helps you figure out the shortcuts, so to speak. And it is an important limit as you move through calculus. We use it for other things as well. Let me try another one. So what if I said my function is x to the 1/2 power? So think about what that would look like. Take a second, see if you can write it. All right, so let's work through this. What's our number in front of x going to be? 1/2. Okay, so our power, x to the 1/2 power, needs to decrease by 1. So you're taking this power of 1/2 and subtracting 1 from it. What's that going to be? Negative 1/2. Now again, if you can get to this point now, I'm really happy. But on Monday, we talked about not only negative exponents, but we talked about what a fractional exponent represents. So what I'm going to do is just rewrite this. If you can figure out how I got here, awesome. If you can't, I don't want you to worry about it right now. Okay, if you can get to that now line, you're in really good shape. But if I were to rewrite this so it does not have any negative exponents or fractional exponents, it would look like that. Again, if you can figure out how I got there, fantastic. I want you to write your answer that way. If you can't, that's okay. I will take that answer as 1/2 x to the negative 1/2. Those are also acceptable for now. Next year, you'll take the time to go through a process that'll help you get to that next year answer. All right, so let's kind of make this a little more interesting, and let's talk about what would we have if I gave your function to you in a slightly different manner. So what if I gave you the function 1 over x to the 3rd power? So now we have an issue, and here's our issue. I can't find the derivative if I can't use this shortcut to find the derivative if my x to some power is in the denominator. So the first thing I'm going to need to do is rewrite this. And again, this is why we did what we did on Monday. I want to be able to rewrite this so that it does not have the exponent in the denominator. What would that look like if I rewrote this so the exponent was not in the denominator? Good. Remember that negative exponent helps you do reciprocals. So I want to move this so so it's in the numerator. So I would rewrite this as just x to the negative 3rd power. That's what my f of x is. And then we can go back to what we just did a minute ago, and we can figure out what our derivative is. Now we just use this format of it to find our derivative. And we did one similar to that up above. All right, we take that power, using our shortcut, take that power, multiply it by whatever the coefficient is. In this case, that's just 1. Negative 3 times x to what power? Negative 4. Reduce that power by 1 means subtract 4. If you can get it here, that's great. If you can do that final rewrite to get it in the form without a negative exponent, even better. So this is good for now. Next year, you'll have to write it like this. Okay? So again, this is now, next year. If you want to challenge yourself and try to get to that next year format, you can. So again, let's bring in what we talked about on Monday. So let's say I gave you f of x equals 1/2 times the square root of x. So just like I did up above, I want to take a minute and rewrite this because I can't use my shortcut if I don't have an exponent. I've got to have an exponent. And we talked about on Monday how we can rewrite our square roots using exponents. So that's the first thing I'm going to do is just take a second to rewrite this. This is not finding the derivative, right? This is just rewriting that expression. So I could rewrite it as f of x equals 1/2 times x to what power? What power represents a square root? That would be squared. So if I raise 4 to the 2nd power, I get 16. If I do 4 as a square root, I get 2. So those are very different. So what was the other type of exponent we talked about on Monday? Fractional. So remember that square root can be written as a 1/2 power. And go back and look at your notes from Monday or the homework from Monday because that's where we spent some time looking at that relationship between roots and their exponents. So if I wanted to find the derivative of that, I guess I can do that over here since it's underneath it. I'm going to take my power, 1/2, multiply it by my coefficient, also 1/2. So in this case, that ends up being 1/4. Times x to the what? Negative 1/2 again. Very much like what we did in the problem up above. So this is now If you wanted to write it like you would next year, it would look like this. And again, I'm not going to spend time on how I get this. If you can figure it out, you can go to that. If not, you don't need to, okay? I just want to give you the preview and the challenge if you'd like it. Okay, do you have questions on this process? It'll make finding derivatives, it'll make finding the slope of your tangent line so much faster if you can use this, yeah.
Can you just go over like that, just this last part, like the top, like the rewrite thing?
Yeah. So one of the things we talked about on Monday was that you can take any square root, cubed root, fourth root. So the square root of x would be the same as saying x to the 1/2 power. The cubed root of x would be x to the 1/3 power. The fourth root of x to the 3rd power, we said would be the x to the 3/4 power. You remember doing that on Monday?
Yeah, and so then that's why you took the square root off and you added the 1/2
The exponent.
power.
Yep.
Okay, I get it now.
Yep. So we're just rewriting it so that it has a power, because we can't use the power rule if there isn't a power. Okay. On the assessment for this, there will be a section on it that I require you to use the limit. So you need to be able to use that limit. So on 10.1 and on 10.3 last night, make sure you're practicing with that limit, because I'm going to ask you to do it on the quiz. And then there'll be a section where I say, just find the derivative. And I don't care how you do it. If you want to use the power rule, if you want to use a limit, either one, whatever you're most comfortable doing. But it does not, that won't have any requirements on it. Awesome. Any other questions? Okay.